That is the property of the ACID. However, in big data system, you probably heard about the Hadoop or the MapReduce programming, such a NoSQL database. They cannot keep all of these properties. Instead, they lose one or two property in their transaction concept. Okay? For what? For performance. They need to handle big data. Even though they lose some consistency, it doesn't matter. Think about we have 100 years of census data. Even though we lose one or two data, so for example, my census data is for my name, my age is changed or lose some information. It doesn't affect some overall statistics, right? Average may not be changed a lot. So what is the average? The member, the house member, how many children on average? The 100. Even though I lose one or two data, it may not affect a lot. So still 2 point something, right? So even though we lose such a consistency or isolation level, such a durability, we can speed up such a big data processing. That is the idea of big data. Okay, then once we have the multiple transaction, the system should guarantee the transaction should be processed successfully in order. Then how can we make that order? Okay, without losing the data consistency. That is called transaction schedule or history. Okay, but I'm not going to explain details of it because we have a couple of more topics after this. So that is called anyway schedule, transaction schedule. So in this there are different isolation level, such as the read, uncommit, commit, and repeatable, read, the serializable, and so on. In this chapter, we will discuss about the techniques for concurrency control that I mentioned. So basically, the relational database management system uses two-phase locking. Two-phase locking. What does it mean? It's a locking mechanism that has two phases. One is locking phase. So you are going to gathering the lock. Okay, once your transaction is done, it's going to be releasing the lock. The transaction does not wait until you acquire all the lock, eventually acquire lock, phase of locking. Then once it's done, it's eventually release the lock. That is called the two-phase locking mechanism. So we will see details about the two-phase locking. So why do we need such a concurrency control? We discuss a lot, but we'd like to formalize the problem. So you have already learned that this conflict in your operating system. If you do not take it yet, so you will learn that this kind of thing. This is a conflict situation. So in case we have the two different transactions, transaction 1, transaction 2. They are accessing the same data item X. Also, one of them should be, both of them are read. Is there any problem? No problem. No matter how many transactions are reading the data, they can read. Of course, it's just a read only. However, in case there is a wide writing, that may cause, not that must cause, may cause conflict. This is called a conflict situation. In case conflict situation, we need to solve that problem. Otherwise, no problem. So, for example, R means read or writing. So first letter indicates read or writing operation. 1 means transaction number. The next one is transaction number, and inside the parenthesis is the data item. So in this case, this is transaction number 1, read the data item next. Transaction number 2, write the data item next. Is it complete or not? Check. How many transactions? 2 transactions. Do we have the read and write? Yes, we have the write. They are accessing the same data? Yes. So complete. We need to, there might be problem, concurrency problem. We need to address it, such a problem. How can we do that? We will see within training. And what about this one? Reading, transaction 2, read the data, item X, and transaction 1, write the data, item X. Same data, 2 transaction, and writing. It's a conflict. Why this is not conflict? Both of them are reading. What about this one? They are accessing different data. Whatever they want, they can do it. Because it's not same common data. What about this one? So one transaction, no problem. So not complete. So in case complete, we need to address that problem. What about the operating system? Operating system may have a similar problem, complexity, race condition. Okay? How can they solve the problem? There are different ways. Okay? They can use the locking and deadlock prevention, deadlock, whatever. Who is a similar solution over here? If you already learn in your operating system, probably easy to understand. Okay? So our solution in database is a two-phase locking. So which means there are 2 steps. One is the locking phase, and another one is the unlocking phase. So there is a lock item X. There is another unlock item X. Release the resource, and the next one will take the resource X. There are 2 types of lock in database: read lock and write lock. Read lock is shared lock, which means everybody can share the same data item. On the other hand, write lock is exclusive lock. Only one guy, one item, or one transaction can take the lock. That is the difference. So there are 2 types of lock. One is a shared lock, another one is the exclusive lock. The shared lock is a read lock, exclusive lock is a write lock. Okay? So in case read and read, no problem. But in case you have a write, it's a complex situation, then we may cause the problem. Not always, it may cause the problem. So we need to solve that problem too. For what? Concurrency control. Okay. So two-phase locking, we need to manage the lock. So we have the lock table. Lock table consists of a transaction ID, data item ID, lock mode, either read lock or write lock, exclusive lock, shared lock, or pointer to next data item. Which one is the next data item to access? Okay. This is a lock manager. The lock manager is one of the process in your database management system. You start off that some of the DBMS have only one process, which means one process will take care of everything. But most of the system can start multiple processes. Okay? So this is the lock manager. Lock manager manages the lock table. Okay? Database should be well-formed. Well-formed means when you read or write the data, any data item, they need to get the lock. Without lock, they cannot even read the lock. Okay? And also, if it's already locked, then it's done, it should unlock. If the data item is already locked, it cannot, the other transaction cannot bother. Okay? Until that transaction releases the lock. Okay? So that is well formed. This is a kind of assumption. in our two-phase locking. So lock can be implemented this way. This is the skeleton code, but it's a simple idea. So we can, if lock item of x is equal to 0, which means nobody lock, then you can set as 1. Otherwise, we need to wait. Unlock, change the value to 0. Okay? And read lock is a shared lock, so you can increase the number of transactions in your read lock. And write lock, only one lock. One transaction can get the lock. In case unlock, during the unlock, in case the shared lock, read lock, you can reduce. Okay? And in case of the reduce and if that is a 0, it is unlocked. There's a lock conversion. Lock conversion means first you can read the date, and inside the same transaction you can update or write the data. At that time you don't have to release the lock, then get another lock. Instead you can promote from shared lock to exclusive lock. That is lock conversion. Or sometimes you can change the lock to read, okay, instead of release the lock. So two-phase locking means growing pace, you can get acquire all the lock, and once that is done, if you do not need such a lock, you can release the lock. So what if there exists a conflict situation? We need to solve that part. If there is no conflict situation, you don't have to do anything. You can let them access the data. So there are 3 different cases. So basic is transaction lock data item incrementally. Okay, that is the basic. But strict is until acquire all the lock, the transaction will not operate, access to the workload. Will not perform the operation. It's a strict case. So in case of basic, that may cause the deadlock. What is a deadlock? Deadlock situation. What is a deadlock?
When two processes try to access the
Only
same
2
resource.
processes sometimes can be multiple.
No.
Yes. In case of 2 process, 2 transaction,
Accessing a single resource.
access single resource.
We like to get
That's locking. That's not deadlock. Deadlock means we cannot move forward. So I'm holding this one. She is holding this one. Right? I need that one. Wait. But she doesn't want to be with me. Instead, she wanna mine. We keep waiting. Okay? That is deadlock situation. Or multiple transactions. 3 transactions. In case of transactions, I'm waiting for this, she's waiting for that, and he's waiting for me. Okay? So how can you detect the lock? You can use graph. Can you? How many of them took the operating system class? Yes. So you draw the graph and find what? Solver. Okay? So wait. What kind of graph is that? Wait. Something wait graph. Research. Who is taking? I think that is the final exam question. Anyway, so you can detect the deadlock situation. So it's the same thing. Because we are incrementally, whenever we need or access the request such a lock. What if she is holding that? She is waiting for me. So it can cause the deadlock. In operating system, how can solve that problem? There are several ways, like deadlock prevention, deadlock detection, deadlock something. It's the same thing. I'm not going to explain details about it because you can refer to operating system class textbook. It's the same solution. Okay? But in our two-phase commit, two-phase locking, who will see the two-phase locking? By the way, how operating system, like the Windows, say the Linux, how can they practically solve the deadlock situation?
Cancel the process, so it releases all its resources.
How?
Tell the users to
Lowest priority for
Nothing. Operating system doesn't do anything for the error. Who is in charge of that? User. Okay? Why?
Because he don't want to
When
control.
users know when the process is
It
going.
takes long time to detect or prevent or solve the problem of deadlock. Also, it requires a lot of research. So, for the performance, operating system doesn't care about the deadlock. Who is in charge of that? User. So that's the reason you need to, from time to time, Control C or interrupt. Okay, send the interrupt signal or force sleep or sometimes restart.
Which is the easiest.
Okay. So actually, the current operating system does not care the deadlock situation. So in database concurrency control, the deadlock may happen. So such a conflict case, conflict situation may cause the deadlock, they may cause the system hang. So we need to, so who is in charge of the database need to solve that problem. How can we solve the problem? Deadlock is exactly the same as your text operating system text. Deadlock prevention. Before you enter the deadlock situation, the operating system or the database engine identify whether deadlock wanna prevent in case something problem prevent or then resolution and avoidance. Always confused. What is the difference? Avoid and the detection. Anyway, avoidance is if deadlock is it enter, so move forward, but it happen, then solve that problem. Okay, to avoid the deadlock. Okay. For that, we database Twophase locking use such a deadlock avoidance. How wound weight or weight die algorithm? We will see what is the wound weight and weight die algorithm. So weight die algorithm means the TS means transaction, and so we have a timestamp. TI is the transaction I. TJ is the transaction date. So TS is the timestamp when transaction is started. This one means TI, transaction I is older than TJ. So timestamp is start from 0 to 10. So which one is younger? 10 was 10. 10 is current. So if that means it's higher, TJ is younger than TI. TI is older than TJ. Okay? At that time, left-hand side is the transaction that caused the deadlock situation. Actually, we cannot guarantee whether this is deadlock or not. It may cause deadlock because it's a conflict situation. So more the conservative. Okay? You cannot guarantee conflict is the deadlock. No. Conflict, in case of conflict, there might be chance deadlock. We don't want to get into this. So, in this case, if this is a conflict situation, check. This one is the transaction left-hand side. That caused the conflict. Okay? Then check with other transaction. That is conflict. Which one is younger? Okay? So, if TI is older, it started earlier. TI start and TJ started here, then TI actually caused the conflict with this one this time. Then we are going to wait until TJ release the resource. The problem is if TS is younger, whenever they have the conflict and wait, it may cause waiting for a deadlock situation. So otherwise, if TI is younger, then at that time we terminate the TI not to enter deadlock situation. That is called wait or but algorithm. Okay? So that is actually deadlock avoidance. To avoid the deadlock. Okay? Wound wait is opposite. So if Ti is older and over and otherwise wait. So many of the two-phase locking use wait time algorithm. That makes sense. Older is it true? During the ferry thing in Korea, my hometown, actually it was a birth head rule, something like that. The children is the first should be escaped, right? During the ship is sinking, and then followed by the lady, then the man, and then the crew member, then captain. So children or lady is the first, but in this case, the older is the first. Older is waiting, but younger, if that is young, then terminate. That's the wait time algorithm. Such a deadlock, if you cannot take care of the deadlock situation, so it may cause starvation. What is starvation? It's the same as operating system also. Okay? Keep waiting, keep waiting. So in this case, so we say if Ti is older, then wait may wait forever. So how can we solve that problem?
We mutate timestamps to
Increase the priority. 1 time, 2 time, 3 time wait, and give the chance to access the data, even though that is younger. Okay? So timestamp is very important at this time to handle such a concurrence control. The next one, last one is the multi-version technique. So I already explained about the multi-version. So far, actually, we do not copy anything. Just use the each data block. We can copy multi-version. Sometimes 1 copy, 2 copy. Until commit, there are 3 transactions that would like to update the same data. Some of the DBMS allow only 1 transaction to update the data, but most of the current DBMS system, they allow to update the data. How? We can copy multiple versions. Okay? Then if committed, yes, apply. There are, but I'm not going to explain detail. That will be very complicated. Okay? Then the last one is the example of the two-phase locking. So I already explained about this one. Okay, this is the example. The last. So we have the 3 transactions over here. 1, 2, 3. And we have 2 operations. Read, write. Okay? B is the begin and E is the end. Okay? Obviously. And we have X, Y, Z item. It can be attribute, it can be table, it can be entire database. Doesn't matter. Anyway, database item. So we need the 2 tables. For the log manager need to manage log table that has item, state, transaction ID. The transaction ID that way for that in case of explicit log. Transaction table is the information about each transaction. Let's start. So first, begin B1 means transaction 1 begins. Okay? Transaction 1 begins. So timestamp of T1 is 1. Then update transaction table like that. Is there any log? Not yet. Nothing. Then transaction 1 read the data item Y. So because this is well from the database concurrence control, they need to get the log. What kind of log? Shared log, read log for data item 1. Then also you need to update the transaction table is active and it access data item 1. No problem. When you execute this one, is it complete? 1.
It's not
No, it's not complete. It's the same.
the
transition, you can go forward. So it's a data item Y, same data item even, and right. So you don't have to release the lock, instead promo. It's a upgrade, promotion. So it's a right lock. You can just update read lock to write lock and data item. There's no problem. The next one, does it cause any conflict? No, it's just still transaction 1. And read data item C and Y and Z. And also C item is read lock by transaction ID 1. Then there is new transaction T3 starting. Okay, their timestamp is 2, whatever. 1, 2. And transaction 3 read data item 1. Is it conflict? 1. This one conflict with the transaction 1. It has the same data item 1 and different transaction and write and read. It's a conflict situation. That means it's the deadlock? No, we don't know. But it's a conflict situation that may cause the deadlock later. We want to avoid. So we need to solve that problem. How? Wait-time algorithm. We need to check whether this is older or not. The left-hand side is a transaction that cause the deadlock. So this is the 2, this is 1, which means this is younger and this is older. So in case the left-hand side, the transaction causing the conflict is younger, we need to avert. So not possible, avert. So this is change it into avert. And what about the T1? T1 is still active and keep the same data item. Okay? And transaction 3 is already averted. So you cannot process this operation. Also averted. And transaction 1, write the data item C, you can just upgrade. Okay? Then Y C. And end transaction 1, commit and release. So there is no log information, but it's committing. Then begin transaction 2, no problem. It's aborted, it's T1 is ended. And no transaction T2 is started, no problem. And write lock on X, yes, you can get the lock. And transaction 3 is aborted. Because it's already aborted over here. And transaction 3 aborted, and read lock, and write lock, and end. That's it. So you can proceed all transaction with such a concurrency control. The key point is whether you can avoid such a deadlock situation. You cannot exactly find the deadlock situation. It needs more research, takes longer time. So you avoid the possible deadlock situation using what? Conflict. Then how can we decide? Either of them should be die. So if you want younger die, that is wait die algorithm. If you want older die, then that is wound wait algorithm. So you can test, wait to test other transition. So this is the Twophase locking, which is popularly used in the database concurrency control. Okay, that's it. So I'd like to wrap up this semester. Next week we do not have a lecture. Instead, you will have the last exercise lab on Tuesday in 1:13. Okay, then Thursday you will have the demonstration on 163.
So no class on there.
No class next week. Okay, so then we will meet on Thursday, the May 8th. Okay, May 8th, the 1:45. I think that takes a 2 hours. So which means it will be difficult, more difficult than the meter. You have the 2 hours. So then you need to check all the grading except the final exam. Okay, we need the GA. Okay, I will give you the chance to check your final exam only on probably Monday. So I will email you. Then if everything is done, I will report as soon as possible because some of the students who are graduating need the grade urgently. Okay? Any question? Thanks so much so far. I really appreciate it for your hard work. But until you got the final grade, it's not done yet. Okay, keep working to get the better grade. Good luck for your final. Thank you.